Hi, my name is Graham Smith, and I'm one of the authors that helped develop the learning approach to mathematics that is found in our textbook as well as the video you are about to experience. To learn more about our approach to learning mathematics, visit the web address that accompanies this video. Now, enjoy the video. Mixed numbers. This video will help you convert an improper fraction to a mixed number, convert a mixed number to an improper fraction, multiply and divide mixed numbers, add mixed numbers, and subtract mixed numbers. Converting improper fractions and mixed numbers. Let's start with some definitions. An improper fraction has a numerator that is greater than or equal to the denominator. The sum of a whole number greater than 0 and a proper fraction is a mixed number. Now let's take a look at some examples that will help us convert between improper fractions and mixed numbers. Example 1. We're asked to convert the improper fraction 7/3 into a mixed number. Well, remember that every fraction is a division problem, and in 7/3 we're taking 7 and we're dividing it by 3. We're going to go ahead and perform this division. 3 goes into 7 2 whole times. 2 times 3 is 6, and when I subtract, looks like I'm going to get a remainder of 1. I'm going to take this information now, and it's going to tell me what the mixed number is. So 7/3 is a mixed number. Well, let's start with the whole number part. Well, 3 divided into 7 2 whole times, so that's going to be our whole number part. And our remainder of 1 is going to be written over the original denominator, which was 3. So the improper fraction 7/3 as a mixed number is 2 1/3. Example 2. We're asked to convert the mixed number 3 1/4 into an improper fraction. Well, an easy way to remember converting a mixed number into an improper fraction is to work in a circle. We're going to start at the bottom, and we're going to actually take and multiply 4 times 3. 4 times 3 is 12. Now we're going to take that answer, and we're going to add that to the top. So 12 plus 1 is going to give us 13. So now that gives us our improper fraction. The numerator of our improper fraction is going to be 13. The denominator is going to stay the same, which was 4. So our mixed number, 3 1/4, as an improper fraction, is 13/4. Now it's time to check your understanding of converting between mixed numbers and improper fractions. Hit pause on your video player and answer these guided practice questions. When you're done, hit play to see how you did. Question 1. Convert 10/4 into a mixed number. To convert from improper fraction to mixed number, remember we divide. And we're dividing 10 by 4. 4 goes into 10 2 whole times. 2 times 4 is 8. When I subtract, I'm going to get a remainder of 2. So now I'm going to take this information and write it as a mixed number. So 4 went into 10 2 whole times. My remainder was 2. The denominator stays the same. So my denominator is 4. So I get an answer of 2 2/4. However, 2/4 is not simplified. So I actually need to simplify that fraction. When I simplify 2/4, I get 1/2. Question 2. Convert 5 1/2 into an improper fraction. To convert from mixed number to improper fraction, we're going to work in a circle. Multiply first, then add it to the top. So 2 times 5 is 10, plus 1 more is 11. The denominator stays the same. So I get an improper fraction of 11/2. Multiply and divide mixed numbers. When we work with mixed numbers, there are lots of steps, so it's easy to make a mistake. To catch potential mistakes, we always start by getting an estimate for the answer. To get this estimate, we round each mixed number to a whole number. For example, to round 4 3/8 to a whole number, we need to round it to either 4 or 5. Which is a better estimate? This question comes down to whether 3/8 is bigger or smaller than 1/2. So here we are, we're taking a look at 4 and 3/8. It's between 4 and 5, but we need to figure out, is it closer to 4 or is it closer to 5? Which really means we need to figure out, is it bigger than 4.5 or smaller than 4.5? So really what we're looking at here is we're comparing 3/8 and 1/2. And we want to know which is larger. Well, let's take a look at 1/2. Half of something. If we're dealing with 8s, half of 8 is 4/8. So really 4/8 is equal to 1/2. So when I'm comparing 3/8 to 1/2, I want to compare 3/8 to 4/8, because now it's easy to see that 3/8 is smaller than 4/8. So over here, 4 and 3/8 is actually going to end up on this side of 4.5, which means it's closer to 4. So when I'm getting an estimate for 4 and 3/8, I'm going to use the whole number 4, because 4 and 3/8 is closer to 4. Now let's take a look at some examples that will help us multiply and divide mixed numbers. Taking a look at our steps, first thing we want to do is get an estimate. So we're going to come up here and round each of these mixed numbers to a whole number. 2 and 1/3. Well, half of 3 is 1.5, which means 1/3 is smaller than halfway. So when I round 2 and 1/3 to a whole number, it's going to round to 2. 1 and 2/7. Half of 7 is 3.5. Well, 2/7 then is less than halfway. So 1 and 2/7 is going to round to 1. So 2 times 1 is 2. So when I get to my final answer here, it should be somewhere close to 2. Now let's take a look at the actual answer to this calculation. Well, the first thing we're going to do is we're going to convert these to improper. To do that, remember, we work in a circle. So I'm going to go 3 times 2 is 6. 6 plus 1 is 7. So that's going to be 7/3 as an improper fraction. And then 7 times 1 is 7. Plus 2 is 9. So that's going to be 9/7. I'm multiplying these. So remember, when I multiply, I'm going to factor them all out first. 7 is prime. 9, 3 times 3. In the denominators, 3 is prime. 7 is prime. So let's take a look here for some common factors to divide out. Looks like I have a common factor of 7. And I also have a common factor of 3. So when I divide these out, it looks like I'm going to get 3 in the numerator. Remember, when all of those factors divide out of the denominator, there's still a 1 left. So I get 3 over 1. Well, 3 over 1 is equal to 3. Now we're going to check that back with our estimate. Well, our estimate was 2. Our answer is 3. Remember, our estimate was not going to be perfect, but that is close enough for us to be confident that we didn't make a mistake in our calculations. Example 4. Divide 4.5 by 3 3/5. Again, we're going to start with an estimate. 4 and 1/2. Well, that's exactly halfway between 4 and 5. Remember, when we're rounding, if we get to halfway, we round up. So that's going to be a 5. And 3 3/5. Well, half of 5 is 2.5. Well, 3/5 then is larger than halfway. So 3 3/5 is going to round to 4. And now you're looking at that going, 5 divided by 4, that's not going to work. Well, it doesn't have to work out evenly. We know how to take 5 divided by 4 and write this as a mixed number. 4 goes into 5 one whole time, and it has a remainder of 1. So for our estimate, we should be getting something close to 1 1/4. So now let's take a look at the actual answer. First thing we're going to do again is convert to improper. So 4.5, 2 times 4 is 8, plus 1 is 9, so that's going to give us 9/2. And 5 times 3 is 15, plus 3 is 18, so that's going to give us 18/5. Now we're going to turn this into a multiplication problem. 9/2 times, we flip the second fraction, so it'll be 5/18. Now we're going to factor this all out. The numerators, 9, 3 times 3, 5 is prime. In the denominators, 2 is prime. 18, I'm thinking 3 times 6. Well, there's 3, 6 is not prime, however, though, so 6 is 2 times 3. Let's look for common factors. Looks like we have a common factor of 3 and 3, another common factor of 3 and 3, and so I get 5 in the numerator and 4 in the denominator. And if that looks familiar, it is, because we just got done doing that problem in our estimate. So 4 goes into 5 one whole time with a remainder of 1, so that is 1 and 1/4. And when we check that back with our estimate, we actually got our exact estimate. So we're very confident that we performed the calculations correctly. Now it's time to check your understanding of multiplying and dividing mixed numbers. Hit pause on your video player and answer these guided practice questions. When you're done, hit play to see how you did. Question 3. Multiply 1 3/4 times 2 2/7. Starting with our estimate. 1 3/4, that is closer to 2, so our estimate is 2. 2 2/7, that is closer to 2, so our estimate is 2. So our estimate then is 4. Now let's take a look at the actual answers. So the first thing I'm going to do is convert to improper. 4 times 1 is 4, plus 3 is 7, so that's 7/4. 7 times 2 is 14, plus 2 more is 16, so I'm going to get 16/7. I'm going to factor this all out. 7 is prime. 16 is 2 times 2 times 2 times 2. 4 is 2 times 2 in the denominator times 7. So let's look. 7s are going to divide out, 2s are going to divide out, and another set of 2s are going to divide out. So I'm actually going to be left with 4 in the numerator, and remember all those factors divided out, but that still leaves us with 1 in the denominator. So I get an answer of 4. And if we check back with our estimate, it actually matches, so we're confident in our answer. Question 4. Divide 4 4/6 by 2 1/3. Okay, let's start with our estimate. 4 4/6. Well, that's closer to 5. 2 1/3, that's closer to 2. 2 will divide into 5 2 whole times with the remainder of 1, so we get an estimate of 2 1/2. Now let's take a look at the actual answer. First thing we're going to do is convert to improper. 6 times 4 is 24, plus 4 more is 28 over 6, and we're dividing that by 3 times 2 is 6, plus 1 more is 7, so I'm going to get 7 over 3. Let's change this to multiplication. So I have 28 over 6. I'm going to flip that second fraction. 3 over 7. Now let's go to factor this all out. 28, I'm thinking 4 times 7. Well, there's 4. There's 7 times 3 in the denominator with 6. 2 times 3. 7 is prime, so it stays prime. Let's divide out our common factors now. Looks like we have a common factor of 2, common factor of 7, and also another common factor of 3. So it looks like we're going to get 2 in the numerator, 1 in the denominator, which is going to give us an answer of 2. Now let's check that back with our estimate. Our estimate was 2 1/2, so our answer is close to our estimate, so we're confident in this answer. Add mixed numbers. To add mixed numbers, we can use the commutative property to add the fractional portions and then add the whole numbers separately. We have to be careful though. We cannot have improper fractions in a mixed number, so we will need to convert any improper fractions back to a mixed number. Now let's take a look at some examples that will help us add mixed numbers. Example 5, we're asked to add 2 1/6 plus 3 7/10. Let's start with our estimate. 2 1/6, that is closer to 2. 3 7/10, half a 10 is 5, so 3 7/10 is actually closer to 4. So our estimate is going to be 6. Now let's take a look at the actual answer. So we're going to use the commutative property to reorganize this. we're going to add the whole numbers together, then we're going to add these fractions together. Well, adding the whole numbers is no problem, but these fractions 1/6 and 7/10 are not like fractions. So we're going to have to come on some scratch work here and build them into like fractions. We'll start with our least common denominator. For 6 and 10, the first multiple they have in common is 30. So the missing multiplier for 1/6 is going to be 5. So that's going to give us 5/30. The missing multiplier for 7/10 is going to be 3. So that's going to give us 21/30. So let's come over here. I'll add the 2 and 3 together. That's going to give me 5. And 1/6 now I'm going to replace with 5/30. And 7/10 I'm going to replace with 21/30. Now I have like fractions, so I can add those together. So 5/30 plus 21/30 is going to give us 26/30. That is a proper fraction. However, we can simplify 26/30. So I'll write the 5 down. Now let's factor this out. When I factor 26, 2 times 13. When I factor 30, I'll think 5 times 6. Well, there's 5. 6 isn't prime. So I'll factor that. Looks like we have a common factor of 2 that divides out. And so my final simplified answer is going to be 13/15. And if we take a look back at our estimate was 6. Well, 5 and 13/15 is very close to 6. So we're confident in this answer. Example 6. Add 4 and 3/5 plus 4 and 4/5. Start with our estimate. 4 and 3/5, that's closer to 5. 4 and 4/5, that's also closer to 5. So we should be coming up with an answer somewhere around 10. Now let's calculate the actual answer. Well, let's go ahead and add the whole numbers. 4 plus 4 is 8. Now I have like fractions here. 3/5 plus 4/5 is going to give me 7/5. But you'll notice 7/5 is an improper fraction. So I need to actually convert that into a mixed number. So what I'm going to have is the original whole number 8, and I'm going to add to that the mixed number that I get when I convert 7/5. Well, let's see. 5 goes into 7 one whole time, and it has a remainder of 2. So that's going to be 1 and 2/5. So I'm going to take that 1 and 2/5 and add that to 8. So I'm going to get 9 and 2/5 for my final answer. And when I go and check that with my estimate of 10, 9 and 2/5 is pretty close to 10. So I'm confident in this answer. Now it's time to check your understanding of adding mixed numbers. Hit pause on your video player and answer these guided practice questions. When you're done, hit play to see how you did. Question 5. Add 1 and 3/8 plus 5 and 1/4. Well, we'll start with our estimate. 1 and 3/8. That is less than halfway. 3/8 is, so that's closer to 1. 5 and 1/4, that's much closer to 5 than it is to 6. So our estimate is 6. Okay. I can add my whole numbers together, 1 plus 5, but my fractions, 3/8 plus 1/4, those are not like fractions. So I'm going to come over on some scratch work and build these into like fractions. So the LCD is 8. Looks like 3/8 has the correct denominator, but 1/4, we're going to have to build that into a denominator of 8. So my missing multiplier is 2. So that's going to give me 2/8. Now let's see. Let's go ahead and add the 1 and the 5 together. That's going to give me 6. And then I'm going to have plus the 3/8. And then I'm going to replace 1/4 with my new equivalent fraction, 2/8. So let's see. That's going to give me 6 and 5/8. And 5 and 8 don't share any common factors. So that's our final simplified answer. Question 6. We're asked to add 7 and 5/7 plus 2 and 2/7. Well, let's start with our estimate. 7 and 5/7. That is closer to 8 than it is to 7. And 2 and 2/7, that's actually closer to 2. So we're coming up with an estimate of 10. Now let's take a look at the actual answer. Well, I can add the whole numbers together. 7 plus 2 is 9. And these fractions are actually like fractions, so I can add those together. 5/7 plus 2 more 7s is going to give me 7/7. Well, 7/7 is equal to 1, so really what I have here is I have 9 plus 1 more, so I get a final simplified answer of 10, and we go back and check that with our estimate. Our estimate was 10, so we're confident in this answer. Subtract mixed numbers. To subtract mixed numbers, we can use the commutative property to subtract the fractions and the whole number separately. However, we will need to borrow if the fraction we are subtracting is greater than the fraction we start with. Now let's take a look at some examples that will help us subtract with mixed numbers. Example 7. I'm asked to subtract 5 1/6 away from 7 1/2. Well, let's start with our estimate. 7 1/2, exactly halfway between 7 and 8, so we round that up to 8. 5 1/6, much closer to 5 than it is to 6, so we're going to be subtracting 5. So we get an estimate of 3. Now let's take a look at the actual answer. Well, if you look at our fractions 1/2 and 1/6, those are not like fractions. So I'm going to need to build those into like fractions. So I'm going to come off on some scratch work and build these into like fractions. Let's start with the LCD. My denominators are 2 and 6. The LCD is going to be 6. So if you look, 1/6 already has the correct denominator. So all I have to do is work with 1/2. I want a denominator of 6. My missing multiplier is 3. So that's going to give me 3/6. So now let's come back up here and rewrite the original problem. So 7, we're going to replace 1/2 with 3/6 minus 5 and 1/6. Now you can see I can take 1/6 away from 3/6, so I don't need to borrow here. So let's go ahead and do the subtraction. 7 minus 5 is 2. 3/6 minus 1/6 is going to give us 2/6, and we can simplify that 2/6. So I'm going to factor that. 2 is prime. When I factor 6, divide out the common factor of 2. So it looks like my final simplified answer is going to be 2 1/3. When I compare that to my estimate of 3, it's pretty close, so I'm confident in that answer. Example 8. Subtract 2 2/6 away from 3 1/6. Well, again, we'll start with our estimate. 3 1/6, that's closer to 3. 2 2/6, it's closer to 2. So we should be coming up with an answer something close to 1 here. Okay. I have like fractions here. I'm trying to subtract 2/6 away from 1/6, but I can't do that. I can't take 2 away from something that I only have 1 of. So I'm going to need to borrow. So I'm going to borrow from that 3. And so here's what I'm going to do with the 3. I'm going to borrow 1 from that 3, which is going to leave me with 2. The 1 that I'm borrowing, I'm going to write as a big fat 1 here. I want to write that as a fraction. And I'm going to write that as the fraction 6 over 6. The reason I'm choosing 6 is because it matches the denominator of 6 that I already had. The reason I wrote 6 over 6 is because, remember, fractions where the numerator and denominator are the same, that's equal to 1. And I don't want to change the value of 3. You can see that I still have 2 plus 1, or 3 there. Now I'm going to write down the rest of the problem. Now I'm actually going to add the fractions in that first part of the problem. So 6/6 plus 1/6 is 7/6. So I'm actually going to end up with 2 and 7/6 there, minus 2 and 2/6. Now that I've borrowed, you can see I can subtract with those fractions. So 2 minus 2 is 0. 7/6 minus 2/6 is going to give me 5/6. 5 and 6 don't share any common factors, so that is my final simplified answer. And if you come back and take a look at our estimate of 1, 5/6 is very close to 1, so I'm confident in this answer. Now it's time to check your understanding of subtracting mixed numbers. Hit pause on your video player and answer these guided practice questions. When you're done, hit play to see how you did. Question 7. Subtract 4 1/4 away from 8 1/3. Well, we'll start with our estimate here. 8 1/3, that is closer to 8 than it is to 9. 4 1/4, that is closer to 4 than it is to 5. So when I subtract, 8 minus 4 is 4. I should be coming up with an answer somewhere around 4. Now let's take a look at the actual answer. Well, looking at my fractions 1/3 and 1/4, I don't have like fractions. So I need to come off on scratch work and build these into like fractions. So 3 and 4. My LCD is going to be 12, and I'm going to need to rename each of these fractions. So I've set up my framework. Let's start with 1/3. The missing multiplier there is 4. So that's going to give me 4/12. With 1/4, my missing multiplier is 3. So that's going to give me 3/12. Now let's replace these values. 8, I'm replacing 1/3 with 4/12. I'm replacing 1/4 with 3/12. Now I have like fractions, and you'll notice I'm trying to take 3/12 away from 4/12, so that's okay. So I can actually go ahead and do the subtraction. 8 minus 4 is 4. 4/12 minus 3/12 will give us 1/12. Now let's check back with our estimate. Our estimate told us we were going to get an answer somewhere around 4, and we've done that. So we're confident in this answer. Question 8. Subtract 6 4/9 away from 8 1/9. Well, let's start with our estimate. 8 1/9, that's closer to 8. 6 4/9, ooh, that's close. Let's see. 1/2 and 9 is 4.5. Well, 4 is smaller than 4.5, so that's actually closer to 6. So we're going to have 8 minus 6. So our estimate is 2. Now let's get our actual answer. Well, in this problem, we're trying to take 4/9 away from 1/9. Those are like fractions, but I'm not going to be able to do that, so I'm going to need to borrow from the 8. So I'm going to borrow 1 from the 8, which is going to make it a 7. That 1 that I borrow, I'm going to write as a fraction. Since my denominators are already 9, I'm going to write that fraction as 9/9. Now don't forget the 1/9 that I already had there, so I'm bringing down that 1/9 minus 6 4/9. Okay? Now let's go ahead and add those fractions together in the first part of the problem. 9/9 plus 1/9 is going to give us 10/9. So I'm going to have 7 10/9 minus 6 4/9. Okay? Now I have like fractions, and you can see now I can take 4/9 away from 10/9. So I can perform this subtraction. 7 minus 6 is 1. 10/9 minus 4/9 is going to give me 6/9. And I can simplify 6/9. When I simplify 6/9, I'll get 1 2/3. My original answer estimate was 2. That's close to that estimate, so I'm confident in this answer. If you found this video helpful, I encourage you to check out our other videos that we have on YouTube, or visit the web address that accompanies this video to learn more about our approach to learning mathematics.